Everyone, welcome back to the shop. Today we're going to be working on part 2 of this old bandsaw. In this episode, we make metal mustaches, ninja stars, and other pointy things. Just in case you missed episode 1, I added a belt chev, built an adjustable motor mount, and fabricated a cool sawtooth belt guard. For the next project, I want to fabricate something that's going to keep myself safe. So here's the challenge that I'm having with this machine, is that I literally feel that it's out to kill me. Let me show you what I mean by that. Look how close this spinning wheel is down here to my ankle. If someone was careless and they stuck their foot in here, it's going to literally break your ankle off and suck you up with this thing. And the blade is right here too. This is terrifying with how fast this wheel is going to be spinning at 4,000 surface feet per minute. And also the blade on this end. As you can tell, the hook of the tooth is pointed up to where if you were to get close to this thing, your sleeves, your bottom of your shirt, even just your bare flesh, if it were to grab that, it's gonna really make a nasty cut. So I'm challenged because I want to protect myself from this torture device that they've made back then. But as a designer, I want to cover her up, but not make her look like a nun either. So that's the challenge I'm faced with. So let's see what we come up with. The first challenge to building the wheel guard is going to be measuring the saw frame. And this saw has a lot of curvy bits. So the easiest solution is to take a photo with my phone to capture the saw profile. And then I'll transfer the photo to the computer where I can now trace and sketch the guard design. It's now time to throw it up on the water jet and make a test cut out of some scrap plywood I had laying around. Glad I built this template out of wood first, because I've literally pondered over it for the last day or so if I like the look or not. And a couple things come to mind is that I didn't quite get this radius on the back of this arch quite right. It's good, but I left some room to put some hinges in here, because the overall idea is that we'll be able to swing this guard out of the way and change the blade. So I need to have some room for some hinges. That poses another problem. And also that I didn't give myself enough clearance here at the bottom around the holes, and then I don't like this gap in here. I'm going to tighten this up a little bit. But on CAD it always looks good, and now I'm actually able to see some problems, like how wide is this guard going to be when we return the edge around so that it clears the wheel. And it's just a great idea to look at it before we cut it out of the expensive material. I have a couple ideas on how to address how big these holes are. I really didn't want to make them really small and make them look like bike spokes, but I have an idea in mind how we can fix this later. So we'll get to that in a little bit. But overall, I like the idea. I think we cut it out of sheet metal now. I'm happy with it. So I'll make those changes quick on the computer, and then we'll cut it out on the water jet. I'm always nervous that I got all the measurements in CAD correct, because there's no turning back at this point. So this is 12 gauge cold roll steel. Wow, look at that. Look at all these teeth. I counted 142 teeth, and there's gonna be a lot of hammering. I can already picture the hammering now. But look at that, that's pretty cool. Oh, it's heavier than I thought too. I'm excited for the next step. I'm gonna get this off the machine, and then we'll load another sheet up here, and then we'll cut the strips that we can wrap this piece with. So let's get that cutting now. I decided on cutting a 5-inch wide strip. This should be good enough balance to cover the wheels and to keep the flex out of the guard. Got all the pieces here on the table ready to go. And this thing is a giant elephant. How do you eat an elephant? Well, we're just gonna have to take it one bite at a time. And what I did learn from making the belt guard on the last episode, when I was wrapping this piece of strip around the outside of this faceplate here, is that working with small pieces did help, and that on the curve, I started on the point of tangency and worked my way around the curve. Well, this one, I'm gonna start at the center and work around. I think that's going to be the easiest solution to this problem. So hopefully that works, but I'm ready to chop this strip up into small pieces and get to pounding. So hammering montage in 3, 2, 1, go. Once you get the tooth started in the hole and start to bend it over, this really does make a pretty strong bond, and it holds itself together pretty tightly. The look of this guard kind of requires this alternating tab look, and it was a challenge trying to remember to alternate bending the tabs one direction or the other. So here's a quick break in the hammer action. I like the way things are going so far. This is a little bit different than the belt guard that I did last time, where this face plate is 12 gauge instead of 14, so it doesn't quite bend as easily as the 14 gauge that I used last time, but it still bends pretty nice. I gave myself a little bit more room in the slot than I did before too, which really helps get this bend to go around. But overall, it's coming together pretty good. This is going to be the trickiest section next, and that's this inside corner wrapped around to this little point over here. But overall, it's turning out pretty cool. So the idea too is where every one of these pieces of material come together, I will weld and blend them together, so I'm not having to work with such a large piece, which that's helping also. So I got 1, 2, 3 pieces left, and then we'll be able to weld the joints together and continue on. So let's just keep hammering and keep going. With the curve and these cool tabs, it was actually pretty easy to keep the plate square to the body. To get the metal to form close, I found it easiest just to get the basic shape, and then the tabs pull it and suck it tight to the body. So we got the perimeter of this guard pretty much all fitted up, and there's one tool that's been really pivotal on getting this rolled metal in place, and that's been this style clamp right here. And what's unique about it is that this clamp does not rotate when you put force on it. It's a straight push, so it doesn't swivel. And when you look at the two here, when you look at the ends, this thing swivels all over the place, which is great in some applications, and then it spins. But much like how I have it fitted to this piece right here, I'm pushing right on the edge of this material, therefore it doesn't slip off or slide off. I'm able just to straight up clamp it, and it's been a real useful tool to wrap this sheet metal around the perimeter, because I'm constantly trying to use just the framework to pull it and suck it together. So I will leave the link in the description below so that you guys can find them if you guys are ever in need of some more clamps. I'm ready to start welding the whole perimeter together, and I've left like an 1/8 inch gap between the plates. That way I can put 100% fillet weld or 100% fill weld in there. And the best way to fill it up quickly is just to use a piece of aluminum or copper as a backer, which I'm going to clamp it behind my sheet metal, and then I'm able to fill it all up and the weld won't stick to this. And that way it'll also help pull out some of the heat, and this will make it a really quick job to fill these gaps up. So I wanted to create a shadow effect around the holes. So I added this piece of metal spaced off 1/4 inch of the main body. This will create the look I want while also making the hole smaller. With all 142 tabs bent, it's finally time to do a test fit. Well, we got it all installed for a test fit, and I think it fits amazing. And the cool thing I really like is how this sawtooth construction, how we put it together. I think it really does look nice. And overall, the fitment is nice and tight to the machine, which is kind of what we were going for. But also, I really like how I added this shadow box behind there. It really gives this machine some depth, and it also decreases the size of the opening of the holes, which I think looks pretty cool too. So that leads me into the next problem. This guard is just sitting here right now, just floating. We need to be able to make it hinge open so that we can change the blade, and then close it and then make a latch so that it stays there. So there is some space over here on the front to where we can add a latch. We'll have to get creative there. But the main challenge is back here on the machine. Let me show you what I'm talking about. When I look at the machine, I want to add a hinge up here and down here at the bottom to give it its most strength possible, but the machine literally has nothing to mount it to. There's no tapped holes. This is a weird funky shape. So the challenge for me is going to be able to, how do I get a hinge to hold over here but yet still fasten it to the machine? So here's my idea to mount this top hinge. This machine has this big ugly casting that holds the wheel on here, and it's my least favorite part of the machine, but I think we can use that to our advantage. So the idea is to build a bracket that grabs onto these machined dovetail ways at the top, and then make a saddle that will sit and rest on the spine of the machine, and then fill in with a piece of heavy material and kind of follow the contour of the spine, but that will allow us to have something to grab onto for the sheet metal for the guard. And I think this will look really cool and fill this space in and give it the girth that I think it really needs back here. So that's the concept. I hope it works. And I think we can make it cool looking and beautiful and functional at the same time. So let's get started and see what we come up with. I'm trying to keep the saw as original as possible and not have to drill or tap in the frame. This makes things fun and challenging at the same time. This also pushes my imagination to think outside the box. This is the clamp that I designed using this flexure to grab onto this dovetail. The idea behind the flexure is to grip the machine surface without damaging it. And now this gives me a good starting point to design the bracket that's going to hold the hinge. And I started with plywood just to get a general shape and idea of what I want it to look like. And then I switched to something a little bit more fancy, which kind of fits the era of the machine. So I decided on the fancy one with the fancy cutouts, and I'll be making this out of 3/4 inch plate, you know, because 1/2 inch is just too thin and 1 inch is overkill. 3/4 seems just about right. And it's what's on the water jet table right now. So we got this crazily over-engineered hinge bracket, and what this is doing is extending the hinge point off the back of the saw so that the hinge and the door will open without binding. So the hinge kind of needs to be in this location. But I've chosen to tie it up front and on top of this machine bracket, which without drilling holes in the machine, this is kind of really my only option. And I want this bracket that I've built to be elevated off the spine of the machine, about 3/4 to 1 inch spacing. So what I'd like to do is make a saddle, which is going to wrap around the top of this casting and fit the exact profile of the spine of the machine. Now here's the challenge with this, is that this casting is tapered and it has a really rough finish because of the parting line of the two casting members when they poured this. And this is a really hard shape to measure. So how are we going to tackle this? The solution is kind of simple and kind of hard. Let me show you how I'm going to do it. I'm going to do it with this tool right here, and it's kind of this finger profiler, which you can use for moldings and stuff. And I'm just going to copy it. From here, it's really easy to transfer this onto a piece of flat plate, and you can scribe or draw around that edge. So now once you got the template and you want the water jet to cut it out, instead of doing it analog, we got to find a way to get this profile shape into the computer. So how do we do that? In modern day fab shops, this is getting to be a more and more problem. How do we get analog converted into digital so that we can communicate with our plasma tables, our water jets, our CNC machines? And I'll show you a quick little trick on how I do it. Much like we did with the guard, we'll take a photo. From there, I emailed myself the picture and then drug it into SolidWorks and put it into a sketch. I scaled it to the exact dimension of the saw. And what's cool about the gauge is it actually has measurements right on it. So I was able to set the scale according to the plastic gauge itself in the photo. And I was 10,000ths of an inch off in scale in SolidWorks, which is, this is gonna be great. So I grabbed a sketch tool that makes a chord and followed the contour of the radius around the plastic, and then therefore made a solid model of this cool mustache saddle using the photograph. Then the water jet cutting out a big piece of plate steel, and then it's ready for a test fit. Take a look at how nicely this fit. It only fits one way because the casting's weird. Look at that. Nice, perfectly fitted profile piece, grabbing the edge of the saddle. Man, this would be really hard to duplicate without the use of CAD. I highly suggest you guys use CAD, learn how to use it, practice on your own time, learn at home, watch YouTube videos. CAD is just an important tool as a screwdriver here in this shop for me. All right, so now let's put it together. It's now time to make the bushings for the end of the fixed hinge and to fabricate the moving arm that attaches to the door. I'm choosing this heavy material not for the strength, but for the look. This door is over 8 feet tall, so some puny hinges probably just won't look right. Starting with some 1/4 inch magnetic shims. Bracket sits on top. Now this creates the height I need to get to the center line of the hinge bushings. In order to keep these two separate pieces aligned up, I'll be using a pin. Pin will keep things centered as I weld it. I really like having a vise with some dedicated soft jaws. It worked great for getting a cap pressed on the hinge pin without damaging it. I'm really glad I overbuilt this lower motor mount, because it really came in handy to mount the lower hinge to. I thought it was a good idea to add a piece of flat bar to the inside of the door to try to tie the hinges together and take the load off the sheet metal. I wanted to make a knob for the machine that resembled a dead spider, but for some reason I ended up with a 6-legged spider instead of an 8. Well, let's take a look at all my hard work, and I do have to say, this took me a lot longer to build this guard and hinges than I had initially set out to, but I think it warrants it. Look how cool it looks, and I'll show you how it opens up, revealing the two big wheels of the old machine. Look how different that looks with the guard open and closed, and I have this good 10-inch space around the wheels between the guard to put the blade on. And man, just looking at this, I'm already feeling unsafe. Let's just close the guard. And now, with the guard closed, I feel protected. I'm not able to get my foot caught up in it. There's that blade when it runs down the back. I'm not worried about interfering it. With the latch on the front, it's all good and secure. I'm able to adjust the belt tension with the slot. And to address these big holes, yes, someone could stick their hand in there and get their hand cut off. But I'm not worried about that because literally there's a big spinning sharp blade right here that somebody could cut their hand off. Also, if I really am worried about it in the future, we could put a piece of plexiglass over it to keep the overall look and to make it safe. But I like the way it looks and I'm not going to change it. So it's going to stay just like it is. And how are we going to finish it? Well, you guys gave me so many choices and so many ideas that literally I'm overwhelmed, and I'm not going to do anything with the finish until we see the saw running and operational. That way we know that we don't have to make any changes to it. We don't have to cut anything back up or alter anything, and we'll decide how we want it to look when the saw is running. But thank you guys for the comments. Keep them coming on how we should finish it now that you see the guard done. Please join me in the next episode as we get this beautiful saw actually running and cutting wood, and I'll see you on the next one.